Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about implementation of minimum spanning trees by using the Prim's and Kruskal's algorithm. So, what is a spanning tree here? So, spanning tree is nothing but a minimum weight spanning tree, where this should be applicable for connected and directed graph. So it is going to be connects all the vertices together with minimum number of weights for its edges. And MS tree is nothing but a tree, but it should be acyclic. So for any undirected graph has minimum spanning tree forest, so it should be an union of minimum spanning trees for its connected components. And if a graph has n vertices, then the spanning tree will have n minus 1 edges. So spanning tree, so minimum spanning tree or minimum weight spanning tree is the tree of a connected undirected graph, and here all the vertices are going to be connected with minimum total weights. And MS tree is a tree because it should be acyclic. So for any undirected graph has minimum spanning tree, which is a union of minimum spanning trees for its connected components. Suppose if a graph has n vertices, then the spanning tree will have n minus 1 edges. So let us consider a graph here. So this is the graph with weights. So this and all will be the weights, and this should be a graph. And we have to be find out the minimum spanning tree. So what should be the minimum spanning tree is that. So the spanning tree is the tree where the sum of the wedges weight should be less than minimum. In such a way that we have to find the tree, that the tree is nothing but the minimum spanning tree. So how are going to be obtained this minimum spanning tree? So normally many of them is going to be identified this greedy approach normally. So like so minimum weight 2, and then next one to 8, and then 9. So like this we can able to construct it, but the problem is that so the weight of the spanning tree should be minimum. So in this case, so if I'm going to consider these 4 vertices, so I'm going to construct a spanning tree like this. So this is the one spanning tree I'm going to get it, or I can also get like this kind of spanning tree. I can also get like this. So like this different combination is obtained. Suppose if I'm going to consider this 2, 8, and then 25. 8, 21, and then 25. So the sum of the weight in this one is 45, so it's 35, and in this one it should be 24. And in this one it should be 54. So the minimum weight in this kind of spanning tree is 35, but here in this case is 24, and this one should be 54. So this should be the best minimum weight spanning tree, because the sum of the weights of the edges should be less than minimum. So like this we are going to be find out the spanning tree here. So in this, the first one is that Prim's algorithm. So Prim's algorithm is nothing but a greedy algorithm. So that is going to be find the minimum spanning tree for the weighted undirected graph, and it finds a subset of edges that forms the tree, which should also include every vertex, and where the total weight of all the edges in the tree should be minimized. And the algorithm is going to be operated by building this tree, so one vertex at a time from an arbitrary starting vertex, and for each step you have to add the cheapest possible connection from one tree to the another tree. So the Prim's algorithm is the greedy algorithm, so that is going to be find this minimum spanning tree for a weighted undirected graph, and it finds a subset of the edges that forms the tree, which is also going to be include every vertex, where the total weight of all the edges of the tree is minimized. And The algorithm is going to be operates by building this tree from one vertex and from then ordinary arbitrary starting vertex at each step. So add the cheapest possible connection from one tree to the another tree. So here we're going to have the set of procedures. So how we're going to construct this PRIMS algorithm. First step is that initialize the minimum priority queue, which is going to contain all the vertices, and set the key for each vertex to infinity and the root key set to 0. Set the key of each vertex to infinity and the root key is set to be 0, and the parent root should be set to null. And if the weight of the vertex is less than the key value of the vertex, then connect the graph and repeat this process till the vertex is going to be, all the vertices are going to be used here. So in Prim's algorithm, what I'm going to do is that, so initially you have to be uh, minimum priority queue, which is going to contain all the vertices. Set the key vertex to infinity and the root key is going to be set to 0. Set the parent of the root to null. So if the weight of the vertex is less than the key value of the vertex, then connect the graph and repeat the process till the vertex is going to be used. So in this premise algorithm, so we're going to be consider an input like graph, weight, and then root. So this is the graph, given graph, weight, and initialize this priority queue, which is going to contain all those vertices, and then set the key of the each vertex to infinity. So the key of that each vertex is set to be infinity, and in this one, so the root key is going to be set to 0. So the root key value is going to be set to 0, and the parent root of the root should be set to null. So these three, this and all will be the initialization of this PRIMS algorithm. So then, while the queue is not empty here, so what I'm going to do, I have to be extract the minimum of this. Had to be find out from, and then from each vertex which is going to be adjacent of this. So what I have to do, I have to be set the parent of v as u here, and then make the set the key of that with the weight value of the connected h uv, right? So this is the algorithm how it is going to be work here. So initially set the priority queue, and then where the all the vertices are going to be stored, and then set the key vertex to infinity and root key should be 0, and set the parent root node null. So while q is not empty here, so u is equal to extract minimum of q. So for all, each v that should be adjacent to u, so I have to be considerate. So if v belongs to q, and then what I have to do, I have to be set the parent v as u, and set the key of v which should belongs to the edge of connecting uv. Okay, so consider this. So first one, I'm going to make all the vertices as infinity in this case. So for like this, I have to be initialize all the vertices of the graph should be 0. Then, so first next step, what I'm going to do is, so I'm going to set this uh, as the starting vertex, so which is going to make it as a u here. So from this, so what I'm going to do is that, so I have to find out what is the minimum that, so this should be the minimum. So that's why I have to make indication of the parent pointers. So this should be the starting vertex, starting edge that is going to have the minimum one. So once that one is done, again I'm going to see whether any other minimum weight that is going to be connected, that should be 14. So 14 is to be done. So among this 13 and 14, 3 is minimum, right? So that's why I have to mark this as the u. And next one, from here I'm going to again identify what is the next minimum that is going to be connected with 3. So I'm going to have 8 and 10, but so 8 is minimum, so that's why I'm going to select this edge. And from here again I'm going to select, so what is the next minimum weight I'm going to be consider. So that's why I'm going to do 8. So 8 is going to be marked as the correct one, so 3 8. And then from again I'm going to mark this as u here. And from this, what are the edges that are connected with minimum? So from this node here 3, so what is the minimum? I'm going to find out whether it is 8 and 10. So 8 is the minimum, so I'm going to choose, and this one is going to be marked as current node. And from this, so again I have to find what is the next minimum from this node here. So I'm going to select 2, so 2 is going to be selected. And 15 also going to be stored, but I'm compared this. So when compared with 2 and 15, so 2 is minimum, so I'm going to choose this 2 and mark this as the current node. And from this place, so again I have to find out what is the next minimum from this place. So that should be 4, 5, and then 9. So what I'm going to do, so 4 is the minimum, so again I have to take 9, 4, and this one is going to be replaced with 5. So what I'm going to do, so I have to consider 4. And from this place I'm going to find out 5. So why I'm going to leave this from this place to this place, because if I'm going to consider this edge, so it is going to be form the cycle, so that's why I'm going to leaving this edge and moving to the next one. Next minimum is 9, so 9 is going to be selected, and next one is 15, select. So once you identified these edges which is not making the cycles, so after removing these blue edges, so this should be the obtained spanning tree, spanning tree. So if you look at this, so if I'm going to select this edge, it is also going to form the cycle. So if we are going to select this one, it's also going to form the cycle. So that's why I'm going on selecting this 14 and 10. So I'm going to considering this 9 and then 15. Okay, like this, we're going to be construct this spanning tree, right? So how this one is working, once again I'm going to repeat this. So initially consider a graph here. So first what I have to do is that, so initially I have to mark all the vertices. So initially I have to mark all the vertices should be, so this should be initial graph. So first I have to mark all those vertices should be infinity first. Okay, so once I'm going to select this as the starting node, so initially it should be 0 root node, and from this I have to identify what is the minimum among these two. So that's why I'm going to select 3 here. So 3 is selected. From this again I'm going to choose what is the next one, 14. So among these two, 3 is the minimum edge, so that's why I have to mark 3 as the current node in this case. So next one, so from this place, what is the next minimum I'm going to select it. So 8 and 10. So if I'm going to select this 10, it is going to form the cycle. So obviously we're going to have one option, that is 3 to 8. So from this location again, so what I'm going to do is that, so again I'm going to identify what is the minimum AM from this location. So if I'm going to select 10, it is going to form the cycle. So that's why I'm going to use this. So from 8, again I'm going to choose what is the next minimum, that should be 2 and 15. So among this 2 and 15, 2 is minimum, so 2 is going to be chosen, and I have to again move to 2 as the current vertex. From this again I have to choose what is the next minimum. So 2, 5, 9 is there. So 2, 4 and then 5. So among these two, which is the minimum one? So that should be 4 obviously. So 4 is going to be choose. After that 5. So 5 may not be chosen. So 9 and then 15. So like this we are going to be construct this spanning tree by using Prim's algorithm. And next one is that Kruskal's algorithm. So what is this Kruskal's algorithm? So Kruskal's algorithm is a minimum spanning tree algorithm. So which is going to find the edge of the least possible weight so they connect any two trees in the forest. So it is the greedy algorithm, and so adding the increased cost arcs at the each step. So that means that it is going to find the subset of edges so that forms the tree which include every vertex and where the total weight of all the edges of the tree is going to be minimized. And to visit all the nodes so with minimum cost with the cycle form. So the Kruskal algorithm is the minimum spanning tree algorithm, which is going to find the edge of least possible weight that connects to any two trees in the forest. So this Kruskal algorithm also follows the greedy algorithm, so adding the increased cost of at the each step. So this means that it is going to find the subset of edges that is going to form the tree that includes every vertex, where the weights of all the edges in the tree is going to be minimized. So to visit all the nodes, so the minimum cost and without the cycle formation. So this Kruskal's algorithm is going to be find this greedy algorithm. So which is going to be add increasing cost of at the each step. That is the main step here. And while adding this edge, we have to be know whether the cycle is forming or not. And let's see this Kruskal's algorithm. So in this one, the tree is going to represent the tree edge, vertices, and then vertex. So in this, initially how to make the tree as high in this case, whereas in Prim's algorithm, it is going to store all the edges in first, and then for each vertex of this vertices, so have to mark as set, and then what I have to do is that we have to sort all the edges in increasing order of weights, and for each edge of this we have to find the set whether it should be equal or not, and then we have to append it to the tree, and then apply this union operation for finding the set u and then set v. So where it should be able to identify the better edge of the graph. Okay. So in Prim's algorithm, we are going to be store all these vertices to be infinity in case of Prim's algorithm, whereas in this case, we have to make this tree as nil. And for each vertex of this one, we have to mark it one, and we have to be sorted in increasing order of weight. And for each edge, so we have to find the set u and then v, and then we have to apply the union operation. So what is this Kruskal's algorithm? So this is the graph they given initially. So for this, we have to be identify the Kruskal's algorithm, right? So now this is the initial graph what I'm going to have. So in this Kruskal's algorithm, uh, so first I have to mark all the vertices of this graph should be color one, and then I have to sort all these edges in ascending order. That should be the initial step. So among this one, so what is the sorting order of this? So that should be one. So I'm going to mark it. So first what I'm going to do, so this should be the minimum weight of all the edges in the graph. So that's why I'm going to consider this as the first edge. And from this, what should be the next minimum edge I'm going to consider is 2. So that's why I'm going to construct. And the next one, what I'm going to see, what is the next minimum age? So that is 8. So next minimum weight I'm identified is 5. So 5 is going to be chosen in this one. And then next one, so what I'm going to do is that, so what is the next minimum? 8. That should be 8 in this race. So that's why I'm going to choose 8. So is that 8 is minimum? So minimum. So I'm going to select this. And then next one, what I'm going to do is that, so from 8, what is the next minimum is 9. So whether 9 is going to be added or not, I have to find it out. So if I'm going to consider this edge, so while joining this edge is going to be from the cycle. So that's why this edge is not going to be selected. And then, so what should be the next minimum weight? That should be 13. So 13 is going to be chosen. So whether I have to add it or not. Why? Because it is going to be from the cycle or not, it have to be added out. So I'm going to select this one also. And then what should be the next minimum weight I'm going to consider is 14. So whether it is going to form the cycle or not, it have to be. So it does not form the cycle, so that's why I'm going to mark this one also. And what should be the next minimum I'm going to consider is that 17. So 17 is the next minimum. So we are going to select this. So it is going to form the cycle in this case. So that I'm not able to select this one. And then after 17, it should be 19. So if I'm going to construct this, it is also going to form the cycle. So this one also not going to be selected here. And then next one is 20. 19 is possible, not possible. It is from the cycle. And next one is 21. So 21 is going to be also from the cycle. So it should be not added. And finally, I'm going to get this should be the resultant file spanning tree by using the Kruskal algorithm. Right? So after removing all the remaining things, so this should be removing spanning tree. So the algorithm, the spanning tree what we obtained through Prim's algorithm and then Kruskal's algorithm is same. It may not be different because the weight should be minimum and the tree is also same. Okay. So like this again, I'm going to explain this how we're going to be construct this Kruskal's algorithm for finding the minimum spanning tree. So this should be the initial graph what they given, and in this graph what I'm going to say that is, so I have to be construct this spanning tree by using Kruskal's algorithm. So for this I have to make first all the color the nodes, and then I'm going to choose the starting vertex. So from among this graph what I'm going to do is this, so how the starting edge is going to be selected. So among this all edges of the graph, the 2 is minimum, so therefore I'm going to select this as the first edge of the graph. And the next one, what is the next minimum? That should be 1, and then 5, and then 8, so and then 2, 13 I have to check it out, so 17, 18, and then 20. So like this I'm going to be select this Kruskal's algorithm by using construction of the inverse spanning tree by using Kruskal's algorithm. So I have to check the remaining cases also, and then how to find it out. Right? So I have to check one by one. So what is the next minimum? 25. So 25 is going to form the cycle. 21 also form the cycle. 19 is also going to form the cycle as well. So that's what I'm going to do after removing this blue. Also, I'm going to choose the what is the next minimum for the construction of spanning tree. So once we are going to be note all this, then we have to construct. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.